Hello students, and welcome to the second video of this three-part lesson of where we're going over the chain rule. In this video, we're going to actually be looking at how we're going to apply the chain rule with different functions, where we have square root functions, where we have radicals and rational functions. With all different types of functions, we're going to learn how to actually apply it when you have functions. In our next video, we'll look at how to look at it in graphs and tables. But for now, let's get practice with the chain rule. And let's get started. All right, as promised, we're gonna have several problems, okay? But we're gonna do them the same way, okay? And if you need to write out, okay, what's the outer function, what's the inner function, go ahead and do that. But we're just gonna go into this. So we have f prime of x that we wanna find. And so I'm gonna have that 3, I'm gonna bring it down. So that's gonna be 3, I'm gonna hold on to that middle part. So 3x squared plus 2. And now I'm going to subtract 1 from the exponent. So that's going to be positive 2. But now I need to multiply this by the derivative of the inside. So 3x squared plus 2, that derivative is 6x. And now I can simplify f prime. So f prime is going to be 3 times 6x, that's going to be 18x, times 3x squared plus 2 to the second power. And that's going to be the end of that problem. So now that we've got the chain rule, we don't have to expand everything out. And it takes so much longer to do that. Just use the chain rule. Now we're going to move over here to our next problem. So think about square root of 2x plus 5. Okay, so that's going to be 2x plus 5 to the 1/2 power. And so now when I'm finding g prime of x, I'm going to bring that 1/2 down, so 1/2, and I'm going to hold on to the inside, so 2x plus 5, and I'm going to subtract 1 from the exponent, so negative 1/2. And then I'm going to multiply by the derivative of the inner part. So now I'm going to multiply by 2. All right, so as I go through simplifying this, I notice that these 2's divide out. All right, so now I'm going to have 1 over 2x plus 5 to the positive 1/2, so I flip that into my denominator. And then now I'm going to just write this with the radical, 1 over the square root of 2x plus 5. And so as you see now that we have the chain rule, we can take these complicated derivatives very, very quickly. All right, here we go. So now we're going to find h prime of x in our third problem. All right, and again, I'm going to write it out, x plus 2 to the positive 2/3. That really just helps me keep track of everything. So I'm going to bring the 2/3 down. So 2/3, I'm going to hold on to the x plus 2, and I'm going to subtract 1, so negative 1/3. And then I'm going to multiply by the derivative of the inner function, so x plus 2. So I'm going to multiply by 1. And now I just need to rewrite all of this. So the 1 really doesn't matter. And so I'm going to get 2 over 3 times x plus 2 to the positive 1/3. And now I just write that in radical form. So 2 over 3 times the cube root of x plus 2. And that's my final answer right there. Now we can actually use that function in some way and apply it in something. Now I'm going to move over here to our fourth problem, where I'm going to find the derivative of f of x. So f prime of x is what we're going to look for. And again, I'm just going to write this out. So 5 times x squared plus 2x to the 1/3. And anytime I have a radical, I'm always kind of like doing this in my head. All right, so I'm going to bring that 1/3 down and multiply it by 5. So that's going to get me 5/3. All right, and now I'm going to hold on to x squared plus 2x and subtract 1 from 1/3, so I get negative 2/3. And then I'm going to multiply by the derivative of the inner part. So x squared plus 2x, that derivative is 2x plus 2. Okay, so now I'm going to move everything around to make it one fraction. So I'm going to get 5. And then this radical part, that's going to go into my denominator. So I'm going to have 5 times 2x plus 2. And then in my denominator, I'm going to have 3 times x squared plus 2x to the positive 2/3 now. Now I'm almost done. So what I see in that numerator, 5 times 2x plus 2, I can factor out a 2, or I could just distribute the 5. I'm going to distribute the 5 because I think getting rid of those parentheses might be a little bit simpler. So 10x plus 10 over 3 times the cube root of x squared plus 2x. And all of that needs to go in parentheses because it's still getting squared. And that right there is going to be our final answer in this case. And again, it doesn't look pretty, but the fact that we did that in 3 steps with the chain rule, it makes our lives so much easier. All right, over here, as we're looking into some problems now involving some trigonometry, again, we're going to rewrite this. And the way I'm going to rewrite this is, okay, so this is cosine of 3x squared. And what you notice here is actually I've got 3 functions. I got something squared, I've got cosine of something, and I have 3x. All right, so this is going to be an application where we have multiple chain rules. All right, so g prime of x. Okay, and that is going to be the outer part, so 2, bring that 2 down, and now I'm going to hold on to the inner part, so cosine of 3x, just like that. Then I'm going to so I subtract 1 from 2 and I get to the first power. Now I'm going to multiply by the derivative of the inner part, so cosine of 3x, that's now just another small problem. And you want to think, okay, what is the derivative of cosine of 3x? Well, that one would be simple because you would just apply the chain rule there. So I'm going to apply the chain rule here, and I'm going to get, all right, so the derivative of cosine is times negative sine, and hold on to that 3x. Now I'm going to multiply by the derivative of 3x. And so the derivative of 3x is times 3. All right, so now I'm just going to put everything together. I got a negative, I got 2 times 3, so I get negative 6 cosine 3x sine of 3x. And you notice like everything just kind of falls out, kind of like one of those like stacking dolls that you've seen. Everything just kind of falls out, and then we can just put it together really nicely. And now over here on the last problem of this page, we're going to find h prime of x. And again, we're going to just rewrite this very similar to this one that we just did, where we're going to have sine of 2x plus 1 to the second power. So bring that 2 down, subtract 1, and hold on to the middle. So sine of 2x plus 1. Okay. Now multiply by the derivative of the inner part. So the derivative of sine is cosine. So times cosine, hold on to the 2x plus 1. And then multiply by the derivative of that inner part, so times 2. Okay, and now we're going to put everything together. So I'm going to get 4 sine of 2x plus 1 cosine of 2x plus 1. All right, I don't really see, I don't think there's any identity that goes with that. So I'm pretty sure that this is going to be the final part of this problem. That's just going to be a quick derivative. All right, so now as we're going to go into these last few problems where we're going to actually be applying the different rules of differentiation. So we know the product rule, we know the quotient rule, we've just learned the chain rule. And now we're going to put them all together, okay? So here I've got one function times another function, okay? And I'm just going to think about this x plus 3 part as x plus 3 to the 1/2 power. Okay, so now that I'm going to take this derivative, since it's 2 functions getting multiplied together, that's the product rule. So that's going to be the derivative of the first, so 5, times the second, so the square root of x plus 3, plus the first times the derivative of the second. So this one we would need a chain rule. So bring that 1/2 down, hold on to the x plus 3, and subtract 1, and multiply by the derivative of the inside part, which is 1. All right, so that part doesn't look too bad, but this problem is going to have a lot of algebra that we're going to need to manipulate this derivative. All right, so let me think about this. So I'm going to hold on to this because I don't really want to work on the left side yet. So 5 times the square root of x plus 3 plus, all right, what I want to do here is I just want to put this as one fraction. All right, so what I'm thinking is that's 5x times 1 times 1, so that's going to be 5x in my numerator. And then in my denominator, I'm going to get 2 square root of x plus 3, because the x plus 3 is negative 1/2. All right, now what I want to do is I want to make this all one fraction, so I need to multiply this term right here times 2 square root of x plus 3. Okay, and let's see what happens. All right. So I'm going to get 5 times 2. And actually, I want to clarify that I'm not just multiplying that. I'm multiplying by 2 over square root of x plus 3 Like I'm multiplying it by 1 here to make a common fraction. So just to be specific. And so 5 times 2, I'm going to get 10. And x, square root of x plus 3 times square root of x plus 3, that's going to be times x plus 3. And then I'm going to have the plus 5x now. And then in my denominator, I'm going to get 2 square root of x plus 3. Because I just kind of combine them all in one step. What I can do here is I could probably distribute the 10. So I get 10x plus 30 plus 5x over 2 square root of x plus 3. And one final step remaining, 10x plus 5x, I get 15x plus 30, all divided by 2 square root of x plus 3. And that right there is going to be our first application of a chain rule within a product rule. And of course, they can come in any different shape or form. So just make sure that you're paying attention to that, because they are going to be coming up and you're going to need to know how to apply them. So this is going to take a lot of practice. In fact, do this problem 2 or 3 times to make sure that you can actually do it on your own. All right, we've got just a couple problems remaining in this video. So right here, we're going to do our derivatives, so g prime of x, okay? And what I have here is a chain rule, so one function inside of another function. So I'm going to take the derivative of the outer function, which is just sine. So that's going to be cosine, and I'm going to hold on to the inner, so 2x plus 1 over x minus 3. Now I want to take the derivative of the inner part. And this is where things get interesting, because I'm going to multiply by that derivative, and I'm going to need a quotient rule. So I'm going to multiply here by x minus 3 times 2 minus 2x plus 1 times 1 all over x minus 3 squared. All right, and again, this is just going to take the algebra stuff to simplify everything. So I'm going to hold on to the cosine of 2x plus 1 over x minus 3. That's not changing. But over here in my second part, I'm going to need to distribute a lot of stuff just to see what happens. So 2x minus 6, and then over here I have minus 2x minus 1 over x minus 3 squared. What I notice here is that I have positive 2x and negative 2x, and those are going to cancel out. And so I get negative 6 minus 1, which gets me negative 7. So over here, I'm going to get cosine of 2x plus 1 over x minus 3. And I'm going to multiply that by negative 7 over x minus 3 squared. And that's going to be my final answer. Again, it doesn't need to look pretty, and in fact, it may not. But you need to be able to apply these different rules very quickly back to back and just be very comfortable with it. And now we have our final problem here of this video. And so we want to find h prime of x. Again, I'm just going to make a note here that this is 2x plus 5 to the 1/2 power. All right, so I'm going to get h prime of x, and that's going to be what I'm doing here as I'm going through this problem. This is going to be an application of the quotient rule. So I'm going to get x minus 3 times the derivative of the square root of 2x plus 5, and that's where I'm going to have a chain rule. So I'm going to bring the 1/2 down. So I'm going to have the x minus 3, I'm going to bring the 1/2 down. I'm going to hold on to the 2x plus 5, but then put that into make it negative, so subtract 1 from that 1/2. And I'm going to multiply by the derivative of the inner part, so times 2. Minus the 2x plus 5. I'm going to keep that in this form with the rational exponent, times the derivative of x minus 3, so times 1. And then I'm going to square that denominator. So this one is going to be a problem where it's really going to test your algebra skills. Okay? So what I notice as I'm doing this is that these 2's are going to divide out, and I'm going to do a lot of work in this numerator. All right, so I'm going to get x minus 3. And the 2x plus 5 with the negative 1/2, that's going to go into that denominator of that fraction in the numerator. So 2x plus 5, the square root of that, minus, and then over on the second part of that numerator, I'm just going to get the square root of 2x plus 5. Kind of just like over 1 right there. One big fraction, x minus 3 squared. Okay, so as I'm doing this, I'm going to multiply this by the square root of 2x plus 5 over the square root of 2x plus 5. All right, just so I can get a common denominator there and combine those. So So I'm going to get x minus 3. And then I'm going to subtract. So I'm going to multiply the square root of 2x plus 5 times the square root of 2x plus 5. And that just, the square roots are gone, so it's just 2x plus 5. But I need to distribute that negative sign. So it's going to be minus 2x minus 5 over the square root 2x plus 5 all over x minus 3 to the second power. All right, let me move down just a little bit because we're going to need some extra space here. All right, so what I'm noticing is that I can combine some things here. So I'm going to get some negatives. So in my numerator, I'm going to get negative x minus 8 over the square root of 2x plus 5. And okay, what I can do here is I'm going to write this over 1, okay? Just so I can think about it in my head, because I'm going to flip and multiply, right? I'm going to multiply by that reciprocal, and I'm going to get 1 over x minus 3 squared. Okay, so nothing's really canceling out, so I'm just going to leave this as a negative x minus 8. So negative x minus 8 over the square root of 2x plus 5. Actually, I think I'm going to write the x minus 3 squared first, because I like to keep the radicals at the end. So I'm going to get x minus 3 squared times the square root of 2x plus 5. That looks probably a little bit neater in my head. And in my numerator, I could actually factor out a negative and put that negative in the front of the fraction and then have x plus 8. But I really don't think that extra step is really going to do anything here. And I know that this problem is a beast of a problem. In fact, you probably won't need to do too many problems that are like this, that are this in depth, especially with the algebraic steps. Okay, that's just not what calculus is about. The calculus is, do you know the chain rule? Can you apply it in different situations? This is really just a lot of algebra, right? The derivative actually happened above. So I want you guys to keep that in mind, right? You do need to be able to do these things. Use these problems like this to really focus your attention and practice your algebraic skills as you move forward in your mathematics careers. Okay, but really focus more on what is the chain rule, what is the product rule, what is the quotient rule, and how can I put those together in different situations. We're going to look in our next video about how those different problems come up in situations where you have graphs or situations where you have tables, and we're going to look at applications of the chain rule in those parts. All right, so stay with it. Just one video remaining. If you do need any help on finding the derivative of these functions, reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.